not Mihai, as you can see. I'm Dalia, but we are part of the same organization in Bucharest, FDN, and our main activity is to participate to the biggest solar houses competition in the world, Solar Decathlon. Apart from that, I'm also part of Future Energy Leaders Romania and Energiata, Your Energy, which is the legislative initiative that managed to change a law in Romania in 3 years and in 3 people, and as a result now energy prosumers are a reality in Romania. Why solar energy? Well, because climate change is real and it is the biggest problem against humanity right now, and I'm not saying that, but the biggest organization in the world are doing so, like World Energy Council, World Economic Forum. And why solar energy? Well, because solar energy is the greatest resource that has the biggest potential to fulfill our consumption in the world. And at a European level, there are actually already laws for that, and we have to till 2030 to reach 32% renewables in the final consumption. And Romania is actually one of the countries in the European Union that has one of the biggest potential from this resource. And despite that, we have very low expectations. Our targets were way below the minimum target, and the European Union urges us to raise our targets. What we actually did is a comparison between normal photovoltaic panels and hybrid photovoltaic panels, which are also thermal panels. And we did that in two stages. One is the actual experiment, and the second one is the simulation. On the experimental side of things, we used 2 panels, one standard, one photovoltaic panel, and a hybrid panel. And what we did, we used the same external conditions, and we measured different parameters with 1 minute time between. What we measured exactly? Well, first of all, the electrical performance with the PV analyzer. We also measured the water temperature, the inlet and outlet temperature water. And we also measured temperatures behind the PV panels and on top of the PV panels, and also the solar irradiance. Well, the results are on the left right there. Is the global irradiance, which is, the test was done in October, close to the autumn equinox, which is a good representation of overall annual average. And on the right side, there are the temperatures on the back side of the solar panels. And what we saw is actually a difference of approximately 5 degrees Celsius between the standard PV panel and the hybrid PV panel. Well, this translates into 10% more energy production on the hybrid panel, because it doesn't overheat. And on top of that, it also generates solar and thermal energy, which is that 2.1 kilowatt hour. On the front side of the panels, the story is completely different. The temperature difference is even bigger. It's 16.5 degrees Celsius. And what we observed are 3 zones. As you can see on the normal PV panel, the temperature is pretty much consistent across the whole panel. While on the hybrid panel, we observed 3 zones. The first one and the coldest one is where the inlet out water comes in. The second one on the top right is the outlet for the water, and on the bottom there's the electrical components, and that's why the temperature is higher there. On the second phase, because we have an experimental on a small scale, but we wanted to see what is the impact on in a real case scenario. So we did a simulation on a house. This house in particular is the one that we participated last year at the 2018 Solar Decathlon in Dubai, and we managed to get 4th place overall, and also the house managed to get 2nd place in comfort conditions and engineering and construction. We use this because from 2020 all new buildings have to be NZEB certified. So we used the thermal properties of this house and took the consumption. We calculated that in Design Builder. We know that Polysan has a component where you can simulate the loads, but our house is very far from standard, so we had to use Design Builder. And that consumption we then put into Polysan. On the system, this is different from the system that is actually in the house, because the house is 100% electrical. Why we did that? Because we wanted to see a more real representation of a standard house. So, on the thermal side of things, the new houses have to be in ZEB, but on the system side, usually in Romania they use gas for heating. So we use a combination of that, and the system looks like this. So we have a combi tank for space heating and also for distribution hot water. The one right there is the gas boiler that heats the water tank, and the second source for the water tank, number 2, is the solar panel. Then we used for space heating we use radiators basically. What is the difference between the first situation and the second is that the second has those hybrid panels instead of the separate PV panels and solar panel. On the electrical side of things and solar, on the panel side of it actually, in the first case we have 32 photovoltaic panels and a separate solar panel. That translates into an output of 8 kilowatts power installed. In the second situation, because we have more space, because we don't use the solar panel, because it's integrated in the hybrid panels, we have lower power installed on the individual panels, but in total we have more, 36, and we actually have more power installed, 8.6 approximately. What we measured is the energy production, the solar fraction, basically how much we produce and how much we consume. And what we discovered is that with the hybrid panels, we actually have a lower consumption, approximately 11% less. And the efficiency of the hybrid panels is approximately 25%. And I don't know if you know, but normal PV panels have an efficiency of about 16%. So this is a good result. In conclusion, what we discovered is that, these hybrid panels are actually worth because they produce 10% more energy, and they stay much cooler, and also they are actually cheaper than a solution with separate PV panels and solar panels. What we want to do next is we want to test and integrate a phase-changing material in the hybrid panels and see how that improves the efficiency of the panels and the obvious cost proposal. Thank you, and now I will leave you with a video of our experience in Dubai last year. It might be interesting, I don't know. Thank you.